let's do some work on this section on integration by parts. Okay, so this, if I take the derivative of this, it's going to be cosine, and I take the derivative, it's going to be sine, and that's going to keep happening. But if I take the derivative of this, it's going to disappear. So that's what I'm going to let u be. U equals x, and du would be dx, 1 dx, and v I'm going to let be this part, v prime, is going to be sine of 3 minus x dx. If I integrate that, see the derivative of negative cosine is sine, but then I'd have times the derivative of the inside, which would be a -1, so I'd have to change this back, because now I'd get the derivative of this would be negative sine times the derivative of the inside would be a negative, it would change it to plus, and so that would work for the derivative of that. So this becomes, according to the rule, it's uv minus the integral of, we used u and dv, so now we're going to use v and du. So uv would be x times that, so it's x cosine of 3 minus x minus the integral of, I use these to set up, so I'm using these two. Cosine of 3 minus x and dx. Now, the integral of this, I'm going to write this here, so we have x cosine of 3 minus x minus the integral of cosine is sine. But if I took the derivative of this, I'd get, again, that negative. So I need to divide by that negative, so that the derivative of this would be actually cosine of that. Now that negative will actually go out and change that sign. So I'm going to have x cosine of 3 minus x plus sine of 3 minus x plus c. Okay, 15. Now 15, neither one of these are going to get simpler when we take the derivative. So you can do this by letting u be one and dv be the other, and it doesn't matter which one you let be which. It's going to do a circular thing, because neither one of them is going to disappear. So I'll start off with letting u equal e to the negative x, and v prime equals sine x dx. Integrate this, v would be negative cosine of x, and the derivative of this would be u prime would be e to the negative x times the derivative of the power, which is a -1 dx. So my first integration by parts would turn into negative e to the negative x cosine x. That's uv minus the integral of what I have left here, which is, we use these, we use those, we go this way. Negative e to the negative x times a negative cosine x dx. Okay, so still got something that looks similar to this, only it's now a cosine instead of a sine. We're going to do another u substitution. Integration by parts, I should say, not u substitution, v prime. We'll let, similar to that we did over here, so we're going to let this be the cosine of x dx. So it integrated is sine x. We're going to let u be e to the negative x. Once again, du would be negative e to the negative x dx. So we had this part, e to the negative x cosine x with a negative in front, almost forgot that, minus, and then we're going to have the integration by parts on this, which is going to be e to the negative x sine x minus the integral of the other two here, which would be minus e to the minus x sine x dx. And if we pull the negative out, that constant, to change that to a plus, this looks exactly like what we started with. And so, if I distribute this negative in here, that makes, if I make this a positive and change that to negative and this to negative, then I can drop these brackets, and then I can add this quantity to both sides of this end equation. Ignore this middle step. Add this to both sides. I can add it to that one too if I want, but add this, the opposite of this, to both sides, and I'm going to get two of those. 2 integral of e to the minus x sine x dx is going to equal negative e to the negative x cosine x minus e to the minus x sine x, and somewhere we need to have a plus c, so I'm going to go plus c, and then I can just divide by 2. Divide by 2, and I can divide by that 2, or just call it the new c. And so we get that for our answer. Once again, this is circle. This had this, and it ended up having it again, and so we add the opposite of this to both sides so that we get some quantity of those equal to what this stuff is. So we're going to have the same kind of situation on 18. Let's see if we can do this. So I'll let u equal e to the 3x u prime equals 3x 3e to the 3x dx. And if I let v prime be the rest, cosine 4x dx, then v equals be 1/4 sine 4x, because the derivative of the sine would be cosine times the derivative of the inside, which would be a 4 times a 4 would cancel and make it 4 cosine x. So this changes to uv, these two multiplied, 1/4 e to the 3x sine 4x minus the integral of these two multiply, which is 3/4 e to the 3x sine 4x dx. Okay. And we're going to do it again. We're going to have this hanging around. So we're going to have 1/4 e to the 3x sine 4x minus, and we're going to do integration by parts on this, but I'm going to pull the 3/4 out. So I'm going to have minus 3/4, and I'm going to let u equal e to the 3x. So u prime equals 3e to the 3x. I'm going to let v prime be sine of 4x dx. So v is negative cosine of 4x, but divided by a 4. So the 4 derivative cosine is sine times derivative inside 4 times this. Derivative cosine is negative sine 4x. And then the derivative inside is 4 times negative 1/4 makes it plus. Because we had a negative already, and it makes it plus 1. So that works. So we're going to have 3/4 of these two multiplied. Negative 1/4 e to the 3x cosine 4x minus the integral of negative 3/4 e to the 3x cosine 4x dx. Ran out of room there. Okay, with a bracket on the end of that. Okay, so now I have e to the 3x cosine 4x, just like we started with. Now, how many do I have here? Well, this minus minus makes a plus. And this minus 3/4 times that says we have minus 3/4 of these. So I'm going to add 3/4 of these to this side. So I'm going to have 1 plus 3/4 more, 1 3/4 or 7/4, integral of e to the 3x cosine 4x dx is equal to this part, 1/4 e to the 3x sine 4x. See, and then we got minus, a minus, that'd be plus 3/16 e to the 3x cosine 4x, and we got rid of this by taking negative 3/4 times this, which is, ooh, wait a minute, did I actually do that? No, I didn't. Negative 3/4 times 3/4 is 9/16. This would be minus 9/16 of these. So I'd have to add 9/16 to 1. So that would be 25/16. 25/16. Sorry about that. Would equal this. And so I'd multiply both sides by 16/25 to get my final answer. So I multiply by 16/25. So I'd have to multiply this by 16/25 plus c. So that'd be 16 over 100 and 3 over 25, because the 16ths would cancel on that. But yeah, that's the idea. Hopefully not making mistakes like I was headed towards. Okay, so now, normally on when we're doing integration by parts, we want things to get simpler, so we set this u equal to u. Except when there's an ln. When there's an ln, we let u be ln, because we don't want to have to integrate ln. We want to take the derivative of it. So u prime would be 1 over x, and v prime would be what's left here, x squared dx, so v would be x to the third over 3. So if we do uv, we're going to get 1/3 x to the third ln x. That's these two multiplied, minus the integral of these two, which is going to be 1 dx, 1 over x times x to the third over 3 dx. And this reduces to just the integral of the x cancels one of those, x squared, and 1/3 comes out. Dx, that's pretty easy to integrate, so we will be able to finish this up. We'll have 1/3 x to the third ln x. So this will be minus 1/3. Integral of that is x to the 3 over 3 plus c. So we get minus 1/9 x to the third. Okay, same idea on this one. Although, with that squared, that's a little bit messy. Do we need to do it by parts? Yeah, let's do it by parts. So let u equal the thing that we're taking the derivative of, which is ln of x quantity squared. So its derivative is 2 ln x to the 1 times the derivative of ln x, which is 1 over x dx. Yeah, and using that chain rule. Let v equal x dx, v prime. So v is x squared over 2. So now we get uv, so that's 1/2 x squared ln x quantity squared minus these two multiplied. So the half and the 2 are going to cancel. X will cancel one of the x's, and so we'll have x ln x dx. And so now we can do integration by parts on this. Again, this has got the exception, so we let u equal ln x. So u prime would be 1 over x dx. V prime will be x dx. V would equal x squared over 2 once again. So we have 1/2 x squared ln of x quantity squared. And then we have minus uv 1/2 x squared ln x. And this minus goes to both of these, so this could be minus and minus. So now this is plus the integral of these two. So that'd be 1/2. And this would be just x would cancel one of those, x dx. This will turn into 1/4 x to the second plus c. So we have this minus this plus that. There we go. Right, the complete answer. There we go. And now the final one is 29. And it looks like we got another cyclic one. So I'll let u equal 3 to the x. Its derivative is ln 3 times 3 to the x dx. I'll let v equal cosine x dx, so v prime. V would equal, the integral of that is sine of x. So we get 3 to the x sine x minus the integral of these, which is ln 3 to the x sine x dx. Okay. And this is a constant. It can come out. And this has got another one, so we're going to use integration by parts. So we're going to let u equal 3 to the x once again. So u prime is ln 3 times 3 to the x dx. And I'm going to let v prime equal sine x dx. So v equals negative cosine x. So this is going to turn into 3 to the x sine x minus these two multiplied, and that'll be a minus quantity, so that'll be plus 3 to the x cosine x, and then that we'd also have minus the integral of these two, and that minus will make it a plus. The integral of ln 3 to the x cosine x dx. All right. And this looks almost like what we started with. There's an ln 3 here that we didn't have before. So writing this down here, we have, I'm going to subtract this quantity from both sides. So I'm going to have integral of 3 to the x cosine x dx minus ln 3 integral of 3 to the x cosine x dx is equal to 3 to the x sine x plus 3 to the x cosine x. And factoring this out of this side, I get 1 minus ln 3 times the integral of 3 to the x cosine x dx equals 3 to the x sine x plus 3 to the x cosine x plus c. I'm going to divide both sides by this. And I finally find out what my integral is that I started with. It's this plus c.